Sixth grade, Module 5, Lesson 4, problem set. Calculate the area of each figure below. Figures are not drawn to scale. Okay, so remember, area is equal to 1/2 times the base times the height. So, looks like we have two rectangles, or we have one triangle right here. So the base is split into two parts, 15 inches plus 6 inches. So together, the base is 21 inches. And then the height is this right here, or the altitude where it creates a perpendicular line or a 90-degree angle. So that is 8 inches. So we have 1/2 times the base, 21 times 8. So let's do 21 times 8 is 168. And then if we find half of that, two goes into 16, 8 times. Bring down the 8, 2 goes into 8, 4 times. So we get 84, our label is inches squared. Number 2. Okay, so again, 1/2 base times height. So here's the base, 72, times the height where it creates a perpendicular line or a right angle. So let's find 1/2 times 72 times 21. I'll do 72 times 21. That's 1,512, and then we need to find half of that. 2 goes into 15, 7 times. Bring down the 1, 2 goes into 11, 5 times. Bring down the 2, 2 goes into 12, 6 times. No remainder, nothing to bring down, so we get 756 meters squared. Number 3. So we have a base of 75 and 8/10. I'm not going to add it to this because that's not actually a part of this triangle. So we have 1/2 times 75 and 8/10 times the height would be this right here, the altitude, 29 and 2/10. So let's do 75 and 8/10 times 29 and 2/10. 2 times 5 is 10, plus 1 is 11, carry the 1. 2 times 7 is 14, plus 1 is 15. Put my 0 down. Done with the 2. 9 times 8 is 72. 9 times 5 is 45, plus 7 would be 52. Carry the 5, and 9 times 7 is 63, plus 5 is 68. Put down 2 zeros, done with the 9. On to the 2. 2 times 8 is 16. 2 times 5 is 10, plus 1 is 11. 2 times 7 is 14, plus 1 is 15. So add all of that together. 5 plus 2 is 7, plus 6 is 13. 1 plus 8 plus 1 would be 10, plus 1 is 11. That would be 12, and 2. Okay, we had 2 digits behind a decimal point. So I'm going to move it over 2 places. We have 2,213 and 36 hundredths, but we're not done. We have to find half of that. So, find a spot to do it. Okay, so it's 2,221. Right there. 2,213 and 36 hundredths. Let's divide that by 2. 2 goes into 2 one time. I'll bring my decimal point straight up. 2 goes into 2 once. Bring down the 1. 2 goes into 1 0 times. So I'm going to bring down a 3. 2 goes into 13. Let's see, 6 times. That'll be 12. 2 goes into 13 6 times. And 2 goes into 16 8 times. So we get 1,106 and 68 hundredths kilometers, or is it kilometers? Yes, kilometers squared. So 1,106 and 68 hundredths kilometers squared. And I don't know, maybe your teacher lets you use a calculator. If she does, that's great. If not, we have the skills to solve this without a calculator anyway. Okay, number 4. So this has a lot of pieces to it. So they've already broken it up into different sections for us, which is nice. So the actual shape is this. It's a pentagon. So it has 5 sides. So let's start with the middle part, this rectangle. Let's start with the rectangle. So it is 19 by 12. Let's do 19 times 12. So that is 228 meters squared for the area of the rectangle here. So this is 228. And then let's do these 2 little pieces on the side, these 2 triangles. So it says that the length here is 5. So the length of that is 5. And then we know the height here is 12. And there's 2 of them, so we'll figure that out later. But so 1/2, since it's a triangle, 1/2 base times height, 1/2 times 5 times 12. So 5 times 12 is 60, and half of that would be 30 meters squared. So we have 2 of those. So this one is 30, this one is 30. So now what we have left is this triangle on the top. So let's do, so the base here would be 5 and 5, and we know this middle part, we can find it right here, is 19 meters. So 5 plus 5 plus 19, well, that would be 10 plus 19, which is 29. So the whole thing is 29 meters. So 1/2, because it's a triangle, 29, times the altitude, or the height they've found for us right there, is 7. So let's do 29 times 7. 9 times 7 is 63. Carry the 6. 7 times 2 is 14. Plus 6 is 20. So we get 203, but we need to find half of that. So let's do 203 divided by 2. 2 can't go into 0. 2 goes into 3 once. Whoops. 3 minus 2 is 1. Okay, so we have a remainder, so I can say 101, and I'm just gonna say and a half, because we have 1 left over out of 2. Or you could write it as 101 and 5/10. Either way. So remember, now we're gonna add all of these together. So let me wipe this clean, start fresh over here. Okay, so this one was 200, this middle rectangle was 228 meters squared. This was 30 meters squared on both sides. And then the top one is 101 and 5/10 meters squared. So we just need to add all of those together, and that'll give us the area of the pentagon. Okay, so let's start with 228 plus 30 plus 30, or 228 plus 60 be 288 plus 101 and 5/10. Get 389 and 5/10 meters squared. Number 5. The Andersons are going on a long sailing trip during summer. However, one of the sails on their sailboat ripped and they have to replace it. The sail is pictured below. If the sailboat sails are on sale for $2 per square foot, how much will the new sail cost? Okay, so they're on sale for $2 per square foot. But first we need to know how many square feet is this sail right here. So let's find the area of the sail. 1/2 base times height. It looks like the base here is 8 feet. Times the height is going to be this section right here, where the base creates a 90-degree angle with the base. So the height is 12. Okay, so I'm going to take a different strategy here, and I'm going to do 1/2 times 8. So we have 4 feet. Half of 8 is 4 times 12 feet would give me 4 times 12 is 48 feet squared. That doesn't answer the question. That just tells us how many square feet we have. Now we want to know how much it will cost. How much does the new sail cost? It's $2 per square foot. So if we have 48 square feet, and it's $2 for each one, times 2, 48 times 2 is equal to 96. So it'll be $96 for a new sail. That is our actual answer. Number 6. Darnell and Donovan are both trying to calculate the area of an obtuse triangle. Examine their calculations below. Okay, so here's Darnell. He did 1/2 times 3 times 4. So here's 3 and here's 4. Well, what I notice is Darnell calculated the area of this right triangle right here. I think we're actually trying to find this triangle, because this is the obtuse triangle. So I think Darnell calculated the area of the wrong triangle. Donovan, he did 1/2 times 12. So yep, I see the 12 times 4. So where he got the 4 is he extended the base and found the altitude. So Donovan is correct. Darnell used the altitude, but he was using the wrong dimensions. So let's say Donovan is correct. Darnell, so he used the correct altitude, this right here. He used 4. Used the correct altitude, or height, but he used the length of the altitude. Instead of the actual base. Number 7, Russell calculated the area of the triangle below. His work is shown. Okay, so he did 1/2 times, he did 43, so I see that, there's the base, times 7. Okay, so I see why that's correct. So he found the base, and then he used the altitude as the height. So he says, although Russell was told his work is correct, he had a hard time explaining why it's correct. So we just need to help him explain why he's correct. Okay, so the formula is area equals 1/2 base times height. Russell followed this formula because 7 centimeters right here is the height and 43 centimeters right here is the base. So when he multiplied it all together, multiplied it by half, he is correct. Number 8, the larger triangle below has a base of 10 and 1400ths meters. The gray triangle has an area of 40 and 325 thousandths meters squared. Determine the area of the larger triangle if it has a height of 12 and 2/10 meters. Okay, so like we just said, area is 1/2 base times height. So let's do 1/2, and we want to find the area of the larger triangle. So 1/2 times base. The base is 10 and 1400ths times height. It tells us the height is 12 and 2/10. So let's multiply those out. Okay, 2 times 4 is 8, 2 times 1 is 2, 2 times 0 is 0, 2 times 1 is 2, 1 times 4 is 4, 1 times 1 is 1, 1 times 0 is 0, and 1 times 1 is 1. Add it all together. And then we had 1, 2, 3 digits behind the decimal point, so I'm going to move it over 3 places. So we get 123 and 708 thousandths, but I need to find half of that. So bring my decimal point straight up. 2 can't go into 1, but it goes into 12 6 times. 2 goes into 3 1 time. Bring down the 7. 2 goes into 17 8 times. 2 goes into 10 5 times. And 2 goes into 8, or this should be 0, sorry. 2 goes into 8 4 times. So no remainder, and we get 61 and 854 thousandths. And our label is meters squared. So that's the area of the larger triangle. Let A be the area of the unshaded white triangle. So here's A. It's the area of the unshaded triangle in square meters. Write and solve an equation to determine the value of A using the areas of the larger triangle and the gray triangle. Okay, so we know the whole larger triangle is 61 and 854 meters squared. We know that the gray one is 40 and 325 thousandths square meters. So A plus 40 and 325 thousandths meters squared would be equal to 61 and 854 thousandths meters squared. So let's just solve that, and we can get A by itself by subtracting 40 and 325 thousandths meters squared. So I'm going to subtract it from there. Also, let's see, need to borrow. 14 minus 5 is 9. 4 minus 2 is 2. 8 minus 3 is 5. Bring down the decimal point. So we get 21 and 529 meters squared would be equal to A. And I believe that is the end of the problem set.